Hello pre-calculus students, and welcome to a video on other types of problems related to transformations. For example, the first type of problem, you're looking at a graph already. You don't need to know the equation of the function or the name of the function. All you need to know is that it's a function. In this case, we're calling it f of x. And we want to know what will happen to the function when we multiply it by 3. And then on the outside, and then we want to know what will happen if we multiply it by 1/2 on the inside. And then we want to know what will happen if we subtract pi over 2 on the inside. Okay, so the first one, because this affects the y's only and nothing's happening on the inside, our transformation rule, xy, will go to x 3y, right? It just multiplies all the y's by 3. So what we're going to do is we're going to fill out a scale that has the same ending, and we're just going to go every other one, so pi over 2 would be here. And then the height is going to be what's vertically stretched. So this, instead of being 1 like it is over here, this will be 3. So it will go up to 3. So I'm going to fill that in. You can pause the video and try to do the same. Okay, so what I've done is I've plotted all of the points where this is going to cross the x-axis, all the x-intercepts, and I've also plotted all of the local maxes and mins, and now I'm just going to fill in the curve. Okay, and there it is, vertically stretched by a factor of 3 f of x. Okay, the next one is we're going to look at the same thing, only this time it's going to be affected horizontally, which means the y's will not change at all. So we can just make this 1. It's not going to be a 3 this time. And this time our transformation will take xy. And remember that when this is 1/2 x, it's going to double the x's in the final product, so our final image. So we're going to get 2xy. And when we do that, that means that instead of going, well, when we go to 3 pi, let's see what happens. We're going to still label this 3 pi. So I'm going to ask you to label the rest, and then I'm going to fill in the points. Okay, so what I've done here is I've plotted some points. I should put that one in there. I plotted some points by doubling all of the x's. So that's what the rule is saying it's going to do. So this is going to be a horizontal stretch. So I doubled, first of all, the pi over 2. Double that, you get pi. So that local max moves over to here. The x-intercept, this x-intercept right here, doubled and went over from 1 pi to 2 pi. So there's my x-intercept. And then this local min, doubling that x. 3 pi over 2 doubled is 3 pi. So now I'm just going to connect those points, and you can see the same curve, only it's horizontally stretched. For this third example, the function is going to be moved over, and we know that it's going to move to the right. It's always the opposite. It's inversely related to the input. So in this case, our xy will go to x plus pi over 2, and then y doesn't change. Okay, so on my scale, I'm not going to change the scale, it's just that everything's going to move over. So I'm going to plot these points right here, except I'm going to move them all over pi over 2. Okay, so there's every point that was graphed here, every key point, including the intercepts, of course. Every key point moved over pi over 2, and now the graph looks something like this, and this is a horizontal translation, pi over 2. Notice that it ends at 3 pi. It doesn't make it back down because that would be at another pi over 2, which we're just not going to put on the graph. Okay, in our next kind of problem, we're going to look at a function, in this case the parent function square root of x, from the equation, and we're just going to write the new equation after a variety of different transformations. Okay, so let's first take that square root of x and move it to the right 1 unit. And we know that that function, if f of x is the square root of x, let's call it g of x. Moving it to the right would be the square root of x minus 1. Okay, so why don't you take a second and pause the video and see if you can write the equation when square root of x is shifted down 3 units, and then when it's vertically compressed by a factor of 2. Okay, so there's the answers. Shifted down, vertically compressed. Now, some people don't like this, the way that this is worded, because it says it's compressed by a factor of 2 and yet we multiply by 1/2. But it's a compression, so that's really has to take over. And that's just how these are worded sometimes, and that's how they'll be worded in your homework. So if it says it's compressed, you have to know that it's multiplied by a fraction. If it says it's stretched, you have to know that it's multiplied by something other than a fraction. That's when it's vertically done. All right, what about horizontally compressed by a factor of 2? Give that one a try. Okay, so this time it actually is a factor of 2 because we know that when we multiply by something that's greater than 1 or less than -1 on the inside, that's going to cause it to be compressed. So this is half the width that it would normally be, and that's a horizontal compression. Okay, these next two, let's look at them together, and then I'm going to have you try both of them because they're different, and this is where order comes into play. So in one case, reflect over the x-axis, and then after it's reflected, let's move it up 5 units over the x-axis. Okay, so that's going to be a vertical reflection. And then look at the same thing, only first moving up 5 units and then reflecting it. All right, see if you can get those. Pause the video. Okay, so I've put a bunch of functions in the calculator, and I'm starting out with the square root of x. So let's just kind of take a look at what the square root of x looks like. Okay, and there's the normal function. That's before any transformations. Now for number 5, we want to reflect it and then move it. So let's look at reflecting it, which would be this one. So let's get rid of the original function and reflect it. So here's the reflection now over the x-axis. And now we want to move it. So we want to take that and we want to move it up 5. So it will be the same shape but up here. So if we take the reflection and then up 5, then we can see that one. And there it is. So that equation that you're looking at up here is reflected and then moved. And so that's this one right here, negative square root of x plus 5. Now let's look at the other way around. Let's look at moving it and then reflecting it. So if we move it, we have this one. This is moving it up 5. Let's take a look. There's the square root function moved up 5. Now if I reflect this, it's going to come down here, and it's going to be, instead of increasing, it's going to be decreasing. It's going to start out higher and go lower. So I want to do it like this one. So think about it. Which one do you think it is? And it's going to be this one. And there's the reflection. So let's look at the numbers now. Look at the equations. And when you want to first reflect it, you put a negative in front of it, and then you want to move it up, and you just add 5 to whatever you started with. But when you want to first move it, then you do that. And then the thing to be careful of, and here is the place where the mistakes will happen, is you're negating this whole thing. You're reflecting all of this, so you have to make sure you reflect all of it, which means distribute the negative sign, and it's actually moving the function down as we just saw on the graph. Okay, so why don't you take a minute, pause the video, see if you can apply the same thinking to this, which has 3 things. First, it's going to be horizontally compressed, then translated 5 units to the right, and then reflected over the x-axis. Okay, so try it out. Okay, so first, horizontally compressing by a factor of 3, which means this is going to be bigger than a fraction, so there's that one. Then we take this function, this is where it gets tricky. We take this function and we are translating it to the right 5 units, which means we're really only replacing the x by with x minus 5. So this is what we get. Okay? Then we take this function and reflect it over the x-axis, so that's a vertical reflection over the x-axis. This is our final answer. Okay, I'll just put that on the calculator and show you. Okay, so first let's take a look at the graph, and it's being horizontally stretched. Sorry, horizontally compressed. So it's vertically stretched, horizontally compressed. Now let's look at what the wrong answer would be if you just put in the plus 5 without putting in parentheses. Let's see what happens to the graph. And there's the original, and it didn't move. These are each 1 unit. It didn't move over 5 units. Now let's see what happens when we look at it when you do put in parentheses. Okay, now there's the third one, and that's 5 units moved over. Okay? Okay, these next examples, example 3, we're going to look at all of these actually with the visual aid and with the transformation rule. So first of all, this is easy because it just gives you a point already. We're still going to look at this visually. Okay, so if we have a rule here, f of, it's going to be x, y. What will that go to with this? Well, it's going to be negative x, y, because there's nothing happening on the outside. So negative x, y. And that means that 2, 5 will go to the opposite of 2, 5. Now let's look at that visually. So from a visual perspective, how about a little graph of that point? So we have 2, 5. Let's just plot the point. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So it's something like this right here. Something right around there is 2, 5. Now if we reflect that over, this is a reflection over the horizontal reflection, it's going to come over here, horizontally reflecting over the axis. So it's going to come to negative 2, 5. Just a little visual to see what's happening. All right, with this one, it is on the outside instead of the inside. So here our x, y will go to x, 3y. So our point 2, 5 will go to 2, 15. Okay, and you can kind of imagine it here. If this is 2, 5, and we're vertically stretching it by a factor of 3, it's going to go all the way up here to 2, 15, somewhere way up there. That's the point on that graph. All right, let's look at another case here. So in example 4, now we're not given the point. So in a way it's a little bit harder, but not really, because when we're given intercepts, we really are given points. So suppose that you have the point, a graph, and all you know about the function is that the intercepts are negative 6 and 2. So we have something like this. So here would be a negative 6, and here would be a 2. And that's all we know about the function, That is all we know, and nothing else matters for these questions. All right, so what are the x-intercepts of the graphs of each of these other situations? So if we have f of x plus 3, that means everything's going to move to the left 3 units. So the intercepts will be at negative 9 and 2 minus 3, which is negative 1. So the x-intercepts will be at negative 9 and negative 1. And for this, also our transformation rule, x, y, would go to x, remember it's inverse for the x, so x minus 3, and then y doesn't change. Well, the y doesn't matter because it's an x-intercept and we don't want it to change. It's going to still be at 0. All right, here, what's going to happen to the x-intercepts? Well, let's think about that now. You have this function, and you don't know what else is happening. All you know is the intercepts. What's going to happen to that if you vertically stretch it by a factor of 3? In other words, you multiply the y's by a factor of 3. Well, what are the y's? 0 here and 0 here. They don't change. So when you stretch a function, it doesn't change the x-intercepts. Okay, so another way to think of that is that the rule here would be that x, y goes to x, 3y. And so the x-intercept negative 6, 0 would go to negative 6, 0. Doesn't move at all. And the one that's at 2, 0, that one doesn't move either. That's also at 2, 0. Okay, so those are your x-intercepts under that transformation. What about inside here? Here we have, I'm going to pause it and let you try to figure that out. Okay, so here it is. The transformation rule will go to negative 1/2 x, y. The y doesn't change because we're talking about just something happening on the inside. And by the way, if you're wondering how to get that negative 1/2 x, or why don't we make it positive, we're looking for the inverse of negative 2x. So here's if the function is f of x equals negative 2x, we switch x and y, solve for y, and that's where it came from right there. Okay, I hope you found this video helpful. I'm going to do the last example in another video.